So we've all probably asked ourselves, why are balloons filled with helium? Well, that's the problem we're going to approach today. And to get you started, I want to provide you with a few guiding questions. The first one is, why do materials sink or float? What property will determine this? The second thing I want you to think about is, what is the air mostly made out of? What is its composition? I also want to tell you that the same number of units of a gaseous element or compound occupy the same amount of space, independent of element identity. So what that means is that if you have 10 molecules of carbon dioxide, it's going to take up the same amount of space as 10 atoms of helium. I also want you to think about, how is helium different than other components of air? What makes it unique? And then how does that relate back to the density? So what I want you to do right now is pause this video and then go do some research and see what you come up with. And then once you've come up with your ideas, you can resume the video and see what I want you to get to. So the first question I asked you was, why do materials sink or float? Well, that's determined by the density. So density is a ratio between the mass, which is the amount of stuff, and the volume, which is the amount of space. So if you have something that's really dense, think of like a brick. It weighs a lot, give it for how much space it occupies, and you would think of it as a dense material. Styrofoam, on the other hand, doesn't weigh a lot for the same amount of space, and you'd say that that's much less dense. And you can picture putting a brick in water and watching it sink, where styrofoam will float on top of it. So less dense materials will float in more dense materials, and more dense materials will sink in less dense materials. And that's because if you have a lot of mass, you're interacting with gravity a lot more, and essentially it's going to pull you down, pull that material down, and the other less dense material is going to float on top of it. So air is mostly made up of nitrogen. It's about 78% nitrogen with about 21% oxygen, and then about 1% carbon dioxide, argon, and other trace gases. So I told you to assume that the same number of particles of gas occupy the same amount of space, independent of the element identity. So this means that the volume for the same amount of particles of any gas is the same. So 3 molecules of nitrogen, which is the main component of the air, takes up the same amount of space as 3 atoms of helium. And so that essentially means the volume is going to be constant no matter what gas we're looking at. So what was the other thing that factors into density? The mass. So what contributes to the mass of an element? Well, atoms are made up of protons, neutrons, and electrons. And electrons weigh next to nothing. They're about 2,000 times lighter than those other 2 components. So protons and neutrons weigh about the same, and they're given a mass of about 1 mass unit. They're slightly different. Neutrons weigh a little bit more, but for the sake of this, the difference is negligible. And so each element has a unique average atomic mass that results from the number of protons and neutrons present in the atom. So helium has an average atomic mass of 4. The atomic number right here tells us the number of protons, and the atomic mass tells us essentially the number of protons and neutrons combined on average in an atom of helium. And you can see that when you compare this to an atom of nitrogen, which has 7 protons and it has an average mass of about 14, there's much less mass in the atom. Now, nitrogen is actually found as N2 in our atmosphere, so you have to double that number of components. So nitrogen essentially has an average atomic mass of 28.0 mass units. So you can see here that there's a much higher mass for the same amount of space in nitrogen than there is in helium. So let's relate that back to density. And we said density is the mass divided by volume, and helium has a much lower mass for that given amount of volume than nitrogen would. And therefore, we would call it a less dense material, and it would float in the air.